Hi and hello to everyone. In this video, we are going to see an application of Laplace transform, that is convolution. Okay, convolution is one of the important tools in signal processing. Okay, we will see how to do convolution using Laplace transform. Welcome to the lecture. So this is the first question we are going to solve. The question is, determine the response of the system with the impulse response h of t is given as u of t for the input x of t is equal to e power minus 2t u of t. Okay, so before going into that, we will briefly see what is a convolution. Okay, so if you take a system whose impulse response is h of t, input is x of t, output is y of t. Now everything I have mentioned in time domain. Okay, so what is y of t? Y of t is equal to x of t input convolved with impulse response h of t. Mathematically, this star indicates convolution operation. Okay, what is convolution? It is nothing but x of tau h of t minus tau d tau. Okay, tau ranging from minus infinity to plus infinity. If you look at this operation, what you have to do initially is, in time domain, if you are working with, we have to convert this t to tau, h of t is converted to h of tau. Then we have to fold it, then we have to shift it, we have to multiply, then we have to integrate for various values of t. Okay, so this is the time domain operation for convolution. Right? If we see it very clearly, once we know the impulse response for any input, if we can convolve it, we will get the output. Right? This is I have represented in time domain. Now we will see what is in frequency domain. In frequency domain, things will be converted to S domain. Okay, so h of t is converted to h of s, y of t is y of s, x of t is x of s. So what is y of s? Y of s is simple, it's just a product of input with system function. Okay, this h of t is impulse response. Once I take Laplace transform, it becomes capital H of s, which is the system function, also called transfer function. Just I can multiply with the input. If I can multiply the input with the transfer function or the system function, I will get the output. Okay, now our job is very easier. Say, because instead of going for this operation, multiplication is fairly simple and straightforward. Okay, once you do this, the next step would be, if you can take inverse Laplace transform, you would be getting y of t. Okay, so this is the advantage of going for Laplace transform, right? So you convert the time domain input and the time domain impulse response, just you multiply that, you will get the out, you will get y of s. Take inverse Laplace transform, you will get y of t, right? Okay, now with this in mind, we'll go into the problem. The first problem, if you can see here, the impulse response h of t is given as u of t. Okay, what is u of t? U of t is the unit step signal. This is my u of t. H of t is equal to unit step signal, right? Okay, and what is x of t? X of t, you can see it is an exponentially decaying signal. You can see this is your x of t. You can clearly see u of t indicates for the positive value of time. For the negative value of time, x of t is 0. Right? When t is 0, e power 0 is 1. When time is increasing, we can see it is an exponentially decaying signal. Now, if you are convolving these two things using time domain, it would be very, very difficult. We have to fold, we have to convert everything into tau, then we have to multiply, then we have to integrate. That is very tedious. So instead of that, what we are going to do is, we are going to take the Laplace transform of h of t and x of t. Okay, we very well know that what is the Laplace transform of unit step signal? H of t is given as h of s. For the unit step signal, the Laplace transform is 1 by s. Okay, what is the Laplace transform of x of t? That is x of s. X of s is 1 by s plus 2. 1 by s plus 2. Okay, right? So this is the Laplace transform. Now what is the question? They are asking the question, in the question they are asking about the response. Response is also called the output. Output can be said as the response, right? They are asking what is y of t. Y of t is very simple. It is the Laplace inverse of y of s, or inverse Laplace transform of y of s. So how will you find y of s? Y of s is equal to nothing but, you can already be discussed, input into system function. Input multiplied with the system function, right? So that's it. So we can multiply these two. It becomes, it is 1 divided by s plus 2 multiplied with 1 divided by s. So it is 1 by s times s plus 2. Okay, so we can take partial fraction, a divided by s, b divided by s plus 2. On solving the partial fraction, you will be getting the values of a and b. Okay, the value of a would be, if you solve the partial fraction, I hope you can do that. The value of partial fraction of a is 1 by 2, b is minus 1 by 2, right? So if you solve that, now we plug the value. So y of s is equal to 1 by 2 divided by s minus 1 by 2 divided by s plus 2. So this is your y of s. What we need? We need the output, right? Output should be in time domain. Y of t is required. Okay, so what do you have to do? We have to take inverse Laplace transform of y of s, which is y of t. Okay, so it is 1 by 2. For 1 by s, the inverse Laplace transform is unit step function. For 1 by s plus 2, 1 divided by s plus 2, the Laplace transform is e power minus 2t u of t. So this is the response. Okay, this is the advantage of going for using Laplace transform to find the output or response. Okay, the thing is, you just multiply the input in Laplace domain with the system function, then you take partial fraction, find out y of s. From y of s, if you can take inverse Laplace transform, you will get the output back in time domain. This is much better than doing convolution, right? Okay, now we move to the second problem. The second problem, find the output response of a system with the impulse response is given as h of t delta of t minus 3 for the input, x of t equal to cos 4t plus cos 7t. Okay, for time being we will sketch what is delta of t. This is my delta of t. At 0 it is going to be infinite. At 0 it is going to be infinite. Area under the impulse is going to be 1. Okay. Now what is delta of t minus 3? If you can see, it is minus 3. It is delayed by 3 time units, right? So delta of 3 minus t minus 3. T minus 3 is this. Instead of 0, it would be starting only at 3. It is present only at 3. So this is your delta of t minus 3. Okay, and of course you can see the input. I don't want to sketch it because it is a cos 4t and this is cos 7t. Sum of these two cosine signals. Okay, right. Okay, now since we are not interested in sketching the signal, we are just going to find out the response. So how can I find the response? Just to find out h of s and x of s in Laplace domain. Okay, what is h of s? H of s is nothing but Laplace transform of delta of t minus 3. Okay, what is delta of t? We know already that the Laplace transform of impulse signal, the Laplace transform of impulse signal is 1, right? What is delta of t minus 3? Which is e power minus 3s 1 into 1 times 1. Okay, so this is your this property. This property is called time shifting property. Time shifting property. Based on time shifting property, you have done this, right? I can very well easily explain using this another example. X of t gives, using Laplace transform, x of s. Okay, if x of t is delayed by a time units, it's very simple. It is e power minus as times x of s. Okay, I can give some other examples, some more examples like using unit step. If you say unit step u of t, the Laplace transform is 1 by s. What is the Laplace transform of u of t minus 2? It is very simple. How much time it is delayed? 2 time units. It's 2 time units. It is delayed. So it is e power minus 2s times 1 by s. Okay. So this is the property, time shifting property. Okay, so delta of t is 1, delta of t minus 3 is e power minus 3s. Okay, right. Next, what about the Laplace transform of this 2 cosine signal, right? Because see, using linearity property, if I can find the Laplace transform of this cos 4t, I can add with the Laplace transform of cos 7t. Okay, so we very well know what is the Laplace transform of cos bt. Let me say cos bt is s divided by s square plus b square. This is the Laplace transform of cos bt. So what is the Laplace transform of x of s? You can see here the value of b here is 4. So instead of b, I have substituted the value 4. So it is s divided by s square plus 4 square, which is 16, plus what is the Laplace transform of cos 70? S divided by s square plus 7 square, which is 49. Okay, now we got the Laplace transform of both the impulse response and the input. Now we have to just go find out the output response. First we will do it in the Laplace domain, then we will take the inverse Laplace. Okay, y of s is equal to x of s in times h of s, right? So you multiply these two things, e power minus 3s times, okay, h of s is e power minus 3s times, what is x of s? S divided by s square plus 16 plus s divided by s square plus 49. Okay, now we will see another property which is called time shift s, the reverse of the same property. Okay, we can see it very clearly. We have an exponential term in the, what domain this is? S is nothing but the frequency domain. T is nothing but the time domain. If we see an exponential term in the frequency domain, it would be leading to the shift in the time domain. Okay, if it is, you can see e power minus as. So it's a shift in, the time is shifted by a units. Okay, t minus a. In the same way, we can clearly see here, for this, what is the inverse Laplace transform? What is the inverse Laplace transform? It is the reverse of this, right? Okay, it is s by s square plus a square. The inverse Laplace transform is, so if I go this way, it is the inverse Laplace transform. This side it is a Laplace transform. Inverse Laplace transform goes from the frequency domain to time domain. Okay, right? So if you can see this, I can write this as it is cos 4t. Okay, now what is happening? The t is shifted by 3 time units, so it is cos t 4t minus 3. Right? For the next term, it would be cos 7t minus 3. So this is your y of t. That is, I have taken inverse Laplace transform of y of s. Okay, I have just applied the reverse of this. Okay, right? Now we are in the frequency domain, we are going to the time domain. So I have taken the inverse Laplace of this term, which is cos 4t. Since I can see here e power minus 3s, I am putting t minus 3. Okay, similarly the Laplace transform of s by s square plus 49 is cos 7t. Because of e power minus 3s, I am putting cos 7t minus 3. So this is the response for the given input. What is the input here? For this system function, for this input, this is the output. Okay, now moving to the last problem. Okay, so this is the, if you look at here, they have given the impulse response of a system consists of 2 delta functions. Okay, this is called the delta. Okay, impulse delta function. This is this, they are given pictorially. They didn't given the expression. And the input they have said that it is an unit amplitude square pulse of 1 unit time duration. Okay, they are asking to sketch the output. They are not asking the expression. They are asking draw the output. Okay, so from this, first step would be we have to find the solution, right? We have to find the Laplace transform of h of s. Laplace transform of h of t. Okay. You can see two impulse signals. At the 0 it is having amplitude of 1, at 2 it is having amplitude of minus 0.5. Okay. So I can write this as, first before finding out h of s, first let us write the mathematical expression of h of t, which is delta of t. Delta of t is nothing but this signal. Okay. What about this signal? It is delta of t minus 2, because it is delayed by t minus 2. Okay, and what is the amplitude? It is minus 0.5. So I can write minus 0.5 times delta of t minus 2. Okay, it is delayed. Suppose if it is moving to the left side, we can say it is advanced. Here we would be having delta of t plus something. If the signal is somewhere here. Okay, is it okay? Delta of t minus 0.5 delta of t minus 2. This is your h of t. Okay, next we will try to sketch this part of the signal. That is your input, right? You take the input. What they have given? They have clearly said that input is a unit amplitude. Unit amplitude. Oh, this is your input, x of t. Okay, what is the width? One time unit duration. One time unit duration. Okay, this is the width. Okay, so from this statement, I have drawn this signal. It's a unit amplitude, square pulse of one time unit duration. Okay, now for this, okay, now you try to write this again in the form of expression. How you can write it? If you can recollect it, x of t is equal to u of t, a unit step signal. Okay, unit step signal, we very well know that it will be going up to infinite. From 0 to infinite, it is going to be 1. This is u of t. But if we can compare here, at 1 it becomes 0. That means I am going to add another signal. Okay, which is, what about this? This is t minus 1, right? This is your u of t, this is your u of t minus 1. If I am subtracting these two signals, what happens? If I am subtracting this part of the signal and this signal, okay, u of t minus u of t minus 1, I will get this signal. Okay, so x of t is u of t minus u of t minus 1. Okay, now we can take Laplace transform. We can easily find out what is h of s. For delta of t, it is 1. For delta of t minus 1, it is time shifting property. T minus 2 means e power minus 2s. And for delta of t again, it is 1. Okay, so this is your h of s. Now, what about the x of s? I can write x of s here. X of s, for u of t, it is 1 by s. For u of t minus 1, again time shifting property, one time unit is delayed, so e power minus s divided by s. So this is the x of s and h of s. Okay, now the question is, we need the output. Okay, how will you find the output? Y of t is required. First we will find out y of s. Y of s is h of s multiplied with x of s. So it is 1 minus 0.5 e power minus 2s multiplied with 1 minus e power minus s divided by s. Okay, so if you can multiply, you can even write it like this. Okay, right, try to multiply these two. Okay, if you multiply, you will be getting as 1 by s e power minus s by s, then minus 0.5 e power minus 2s divided by s, then minus multiplied with minus, we will get plus 0.5 e power minus 2s e power minus s, it becomes e power minus 3s, we have a 0.5 here, divided by s. Okay, so this is what your y of s. Now we have to find y of t. If you know y of t only, then not only you can sketch the signal. Okay, so what I have to do? I have to take inverse Laplace transform. I will get y of t. For 1 by s, it is very simple. It is u of t. 1 by s, inverse Laplace transform is u of t. Again, you can see 1 by s is here. Further, it is u of t. You can see e power minus s term. E power minus s term says that one time unit is delayed in time domain. So u of t minus 1. Okay, you can see again here 1 by s, 0.5 is here. So I can put the amplitude as minus 0.5. What about the e power minus 2s? This says that 2 time units delayed. Okay, you just recollect the time shifting property. Okay, for the next last part of the signal, it is amplitude is 0.5. Okay, how much time? E power minus 3s, so it is delayed by 3 time units. So this is your u of t, yeah, sorry, y of t output or response. Okay, now the question is they are asking to sketch it. Okay, let's draw the signal y of t. Let's draw the signal y of t, right? What is its u of t? It's u of t minus 1. Okay, so its u of t means this is u of t. T minus 1 at time 1, what happens? At time 1, another step signal, but it is getting subtracted. Okay, so we will get this part. Okay, and we won't have any signal because this unit step will start only at 2. This unit step will start only at 3. Okay, once it is starting at 2, what is amplitude? It is minus 0.5 because these two signal will contribute to only this part. Okay, t minus 2 at time 2, what is amplitude we have? We have minus 0.5. Minus 0.5, this is 1. Okay, right? And it goes at 3, what happens? It keeps on going, but at 3 again plus 0.5 is added, another step signal. So minus 0.5 plus 0.5, it comes to 0. So this is the signal. Okay, I can advise you to draw each of it individually. Let me say draw u of t separately, u of t minus 1 separately, u of t minus 2, amplitude of 0.5 separately, then you add everything. Okay, you will be getting this. Okay, right? We'll stop here. Thanks for listening. Have a great learning. Thank you.